Hi, welcome to another video. In today's video we are going to find the number of ways to place people. That is second problem in this series, which is a hard question. So the basic premise of this question is they will give a set of points which are represented in Cartesian coordinates that are represented by x and y coordinates, and we need to find out in how many ways we can place people on those coordinates. So there are some conditions. So the conditions are really simple. So we have to place exactly two members. I think they have given the name as well. I think Alice and Bob. So we have to place these two people on a rectangle. So in the sense, so on the top left corner we should place Alice, and on the bottom right corner we should place Bob. So if we place on the bottom, once we have this top left and bottom right coordinates, we can form a rectangle out of those two coordinates. Let's consider this example actually. So here you can see, so if we have the top left corner and bottom right corner of a rectangle, then we can form a rectangle here. So here the condition is, so no other point should come inside that rectangle and on that perimeter of that rectangle. So we need to find out all such rectangles which satisfy this condition. So we have to pick a pair of points which can form a rectangle by becoming top left corner and bottom right corner. And once we have the rectangle, we need to find out if there is any other point which is present inside that range, inside that box. If any point is present inside that box, then that becomes invalid. So we need to find out all such rectangles possible, and we need to return the count. So that is the overall explanation for this problem. I will explain this with diagrams so that it becomes easy to understand. Let's understand what they're saying in the problem statement. So they have given bunch of points, let's say 0, 2, 1, 3 and 2, 5 and so on, 2, 5 and 3, 6, something like this. So we have bunch of points and we need to figure out how many rectangles we can form so that no other point lies inside that particular region. So what we should do is we should pick any two points from these given points, and we should check whether it is possible to form a rectangle. So it is possible to form a rectangle. Let's say this coordinate is cx and cy, and this coordinate is tx and ty. So if this is the case, then let's say we pick two points from the given points. Once we pick those points, we need to decide whether it is possible to form a rectangle with these things. So for that, the condition is very simple actually. Cx should be less than or equal to tx, and cy should be greater than or equal to ty. If this condition is satisfied, then it means if we pick these 2 points, we can form a rectangle here. So the rectangle is represented by this red color. So now we have formed a rectangle. Then we need to check whether any point lies inside this rectangle or on the perimeter of this particular rectangle. So let's say if we pick any random point named x, y. So how can we check whether this x, y lies inside this rectangle, this particular rectangle? So for that, the condition is very simple. The x value should lie between cx and tx, and y value should lie between cy and ty. So if these two conditions are satisfied, then that means if this point lies inside this rectangle. So once we find any such point which lies inside this particular rectangle, this whole rectangle becomes invalid. So we don't count this rectangle in our answer. So similarly, if we don't find any such point which lies inside our considered rectangle, then we will increment our answer count. So this is the brute force way of doing it, where we form pairs, and for each pair we will check whether it is possible to form the rectangle. So once we have the rectangle, then we will check for all the remaining points whether any other point lies inside the boundary. So this is the brute force way of doing it. So we can optimize this instead of doing a brute force way by using sorting the points based on certain criteria, and after that we can make use of the sorted points in order to optimize our approach. Let's consider that approach as well. Let's understand how we can sort the points, and then we can make use of those sorted points in order to arrive at optimized solution. Let's say they will give some points named 0, 2, 5, 6. I'm just considering some random example, 2, 1 and 4, 6 and 2, 3, like this. So then what we are going to do is, instead of going through all the points for every pair, if we sort these points, then we can easily skip the points which come before that particular point. So once we sort with respect to x coordinates, then what we are going to get here is 0, 2, and after that the second biggest x coordinate, that is we are sorting with respect to x coordinates. Here x coordinates are matching. If x coordinates are matching, then we will give priority to the point which has a higher y coordinate. So this is something that we need to keep in mind. I will explain why we give higher priority to the point with higher y coordinate when x coordinate match with each other. So then comes 2, 1. Now these 2 points are over. Then 4, 6. Then 5, 6. So once we get this sorted points, then we can easily skip the points, checking for points which come before a particular point. So let's say we got some rectangle here. So we have this rectangle is formed by these 2 points. Let's say we are considering some of the 2 valid points, and this is a rectangle which is formed by these 2 points. So how can we check? Let's say we consider this point as cx and cy, and we need to check current point. Let's say we consider tx and ty. What is the condition so that this point can form a rectangle? So for that condition should be ty must be less than cy. So if this condition is satisfied, then these 2 points can form a rectangle. You may be asking like why we are not checking the condition for x. So for x we have already sorted. So if we consider points in the order, then we know that obviously tx will always be greater than or equal to cx. So this condition is already satisfied because we are already considering sorted points. So now we got to know that we got a rectangle, and let's say if some other point comes. Let's say we got a point here, another tx and ty. While traversing the points, we got another point here. So now this also satisfies this condition, because here ty is also less than cy for this particular point. So now if we write a rectangle here, that is represented by red color. Let's say we form a rectangle here like this. Now if you ask me whether this is a valid rectangle or not, it is not a valid rectangle, because this particular point here, if you observe this particular point which is present in the middle, so this is present inside. So this whole rectangle represented by red color becomes invalid. So what is the criteria that we are going to use in order to consider only valid rectangles? So let's continue with this example. Let's say we have got a point here let's say we represent it here, and let's say we got one more point here. If I draw the rectangle here using the blue color, I know that image is getting little bit messed up, but this kind of gives us the clear explanation. So if I ask you if this is a valid rectangle formed by, let's say, another point tx and ty, this is valid because there is no point comes inside the boundary of this blue colored rectangle. So we need to increment the count at this point. So what is the criteria that we can use to check only valid rectangles? So here in this case, what we are going to do is, for the first point, let's say we will use a variable named max y till now. Let's say if this is a variable, let's say initially it will be of some minus infinity. If this is the case, so if our current y that is which is equal to ty, if this is greater than the max y seen till now, then it forms a valid. If this condition is satisfied, then it forms a valid rectangle. You can verify this condition in this image once we get assorted points. When we consider this particular point here, ty, the max y seen till now is this particular y actually. So here we are considering a point which is less than, here y coordinate is less than this particular y that we have already seen. So that's why this becomes an invalid point, invalid rectangle itself. But here if you consider, here the y coordinate is more than the y coordinates that we have seen till now. So that's why this rectangle becomes a valid rectangle. So this is the technique that we are going to use in order to solve this problem. I hope you understood this method. If you are having some confusion, you can try out with some valid points, and otherwise you can try to rewatch this part of explanation so that it becomes clear. Let's implement the same solution that we have discussed. So initially what we are going to do is, first we have to sort points based on the condition that based on x coordinate value. So for that we should pass, for this sort we should points the iterators, that is points dot begin, points dot end, and we should provide a customized comparator function for this. So we are going to implement that as well, compare points. So what this function should ideally do is, it should sort points based on the value of x coordinates. So if x coordinates are equal, then it should give priority to higher y coordinate value. So let's implement that function as well. Since we are passing this function to sort function, it should be a static. It returns a boolean type, and the function name should be compare points. So this will take two arrays which represents point A and another point that is point B. So once it takes 2 points, then we need to check if point A of 0, that is x coordinate of A, is equal to x coordinate of B, point B. If this is the case, then we should give priority to the higher y value. So then we will return point A of 1, that is y coordinate of A, is greater than point B of 1. So if that is not the case, then we should give priority to point based on the x coordinate value. Point A is less than x coordinate of point B. So what this function will do is, it will sort the points based on the x coordinate values. If x coordinates are equal, then it will give higher priority to the point which has higher y value. So this is what we are doing inside this function. So once we sort the points, and let's initialize some variable to store our answer. Let's call it valid rectangles count, and we are going to initialize it to 0. And after this, what we are going to do is we will just start iterating over the points. For int I equals to 0, let's declare one more variable named total points, which is going to store the count of points which are given to us, points dot size, and I less than total points I plus plus. So here we can extract x and y coordinate. Cx will be equal to, so what is the x coordinate? That is point of, since it is a 2D array, we have to extract point of I comma 0. So this is the x coordinate, and if you extract y coordinate, that will be point of I and 1. So now we have extracted x and y. We need to declare another variable named max y. So initially, let's say we declare it as minus infinity, so that at least for the first value it considers it as a valid value. So I'm going to initialize it to, I will add some 11 zeros in front of it. 1 2 3 4 5 6 7 8 9 10 11. So this serves as a minus infinity for our problem definition. Here you can see the values. So it's a minus 10 power 9. Also I have given minus 10 power 11. So that is why it acts as a minus infinity for our problem. And after that, we can start iterating over the points starting from I plus 1. J equals to I plus 1. J less than total points. J plus plus. And here we will check this condition. If then here also we can extract tx and ty. Tx will be point of, I think instead of point we should use points here, because that is the name of the variable that is given to us, points of j comma 0. So this is the x coordinate of the point, current point that we are considering, and ty will be points of j and 1. So now we have extracted these 2 points. Then we should check whether it forms a valid rectangle. For that case, our ty should be less than or equal to cx with cy. So if this is the case, then only it can form a rectangle. So we are not checking the value of x because x is already in sorted order, that I have explained it before. So then it forms a valid rectangle. Then it forms a rectangle. In order to check whether it is a valid rectangle, it should satisfy one more condition, that is ty should be greater than max y. So then only it becomes a valid rectangle. So this is, if this condition is satisfied, then we know that any point will not come inside that particular rectangle. So you can refer the diagram that I have shown in the previous explanation. So why we are checking these 2 conditions. If these 2 conditions are satisfied, then we are sure that we are considering a valid rectangle. So at that point we should increment that count as well. Valid rectangles count plus plus, and we should update the value of max y. Max y should be equal to ty. So this is all we need to do, and after going through all such pairs, we just have to return the valid rectangles count. So let's submit this solution and check whether it passes the initial test cases or not. Yes, as you can see here, this solution is passing the initial test cases. Let's submit this solution and check whether it passes all the test cases or not. Yes, as you can see here, this solution is passing all the test cases. If you are interested in learning more about other data structures and algorithm related problems, please check out other videos from my channel. Thanks for watching this video.